When you look at some more problems on primes and divisibility, that will be like company H has 4,000 and 180 pencils evenly in among in its employees, with each employees getting an equal integer number of dollars and an equal integer number of pencils. What is the greatest number of employees that could work for the company? Just understand it once more. Company H distributed 4,000. Let's take 4,000. Irrespective of that, what it's in currency, which currency. Just take 4,000 and then 180 pencils evenly among the employees. So they are distributing 180 with each employee getting an equal integer number of dollars. Well, integer number of dollars. So it's distributing this $4,000 as well as 180 pencils. So for 4,000 pencils, sorry, $4,000, they're getting an equal number, integer number of dollars and an equal integer number of pencils. What is the greatest number of employee that could work for the company H? Mm, there are 9 employees. Okay, if there are 9 employees, so if we distribute this pencils, so they will be able to get the pencils like 20 will be given to a single employee. But what about this currency? For that, it will be like then 4, then 36, then 4. So it will be coming in some point or something like that. So simply this won't be our answer. For next thing, if there are 10 employees, so yes, each one of get 18 pencils, and for currencies they will get like suppose $400 each. Then if there are 20 employees, yes, it can be also distributed as 9 pencils, or and for this they will get approx $200. Then for 40, it will be $100, and it will be for this 40. The pencils will be distributed in point, like I think, in no, not point, they will get 25 pencils, I think, each. And for 180 also, it's getting 1 pencil each. And for here, I think it will be like 4,000 divided by 180, 9, and 200 each. So obviously this can't be distributed. So we have got clear information that I think 180 and 9 couldn't be our answer. And remaining are 10, 20, and 40. So another thing is, in order to distribute this $4,000 and 180 pencils, that is evenly, the number of employees must be a factor of each of these two numbers. Number of employees should be a factor of each of these two numbers. Okay, so if employees a factor, so we need to like first factorize the things. So simply that will be greatest common factor between the things that the employee has. So we will be able to divide the greatest common thing. So for that it should be a factor of these two numbers. One must be a factor. So can do factorization. Let's do for what should I do for 4,000? Let's take it 4,000, no problem. Something big. Will be coming for 2, 2, and 2 many times. Then obviously there'll be a 5, 5t, 5, 10, 5, 2, 2, 1. So like number of twos you can count. So like 2 to the power of 5, I think. Yeah. And for 3, oh, there are no 3, there are only 5. So 5 to the power 3. And for 180, we factorize it fastly. So let's do for 180. So let 180, then 290, 245, then 3, 1, 1, 5, 15, then 3, 5, 5, 1, 2 square, 3 square, 5 power 1. So let's write 2 square, 3 square, and 5 to the power 1. So this is the factorization of this, factorization of this. Now in order to find the number that have in common, simply we can take that number and uh, employee must be a factor of that. Simply the common number would be our answer in this case. That would be, I think, 2 twos are there. Here are 2 twos there and 1 5. So in 2 to the power 5 also there are 2 twos and 1 5 is there approximately in 5 to the power 3. So we get 2 twos and 5 to the power 1 is that. So that would be equal to 4 into 5, that will be 20. And hence our answer is 20. Moving on to the next, it's like 11th and is divisible by 14 and 3. Which of the following statement must be true? Indicate all such statements. So we have got the thing that is n, that we are taking, we don't know its integer or what it is, it's not defined. And they are telling to n is divisible by 14. Okay, and n is also divisible by 3. N is divisible by 14 and n is divisible by 3 also. Means n is divisible by 14, and you can say and n is divisible by 3. And means intersection of 14 and 3. 14 and 3. And we're selling that. Let's look at the options. So I think we need to do prime factorization of this, I think, both the numbers. Let's try doing that, and also use a different approach for that. So it's 7, 3, 21, and 22. And 21 to this is 42. Fitting 20, 42 for there. So finally, n must be 42, the least common multiple of 14 and 3. So n is definitely a multiple of 42. And I think can be 42 also. Or n can be a multiple of 42, as 42 is divisible by both, I think. So first option, there is n is a multiple of 42. So you can also see by that 42 divided by 14 is divisible, and it's also divisible by 3. That is 3 ones are 3, 1, and 3 4 are 12, that is 14. So we see that it's divisible, and 12 is a factor of n. If n is 42, so is 12 a factor of that? Is 12 a factor of 42? Is 12 a factor of 84? Is 12 a factor of 126? So taking in consideration 42, that will be starting, and because we don't have much information, that it can be 42, it can be any multiple of 42, and since we don't know what exactly it is, so and we are asking that 12 is a factor of n, so the 42 cannot be a factor of n. Sorry, 42 means 12 can be a factor of 42, so I think this will be wrong. And for 21 is a factor of n. So if 21 is a factor of 42, that is from 2 za. So I think for 42 multiples, every multiples, going 3, like it's 4 and 2, you can consider. Means if we say that this table similar sounds like the 2 is a factor. So some or the other way, let's trying on to some more numbers like 84 is 21, a factor of that. When multiplied by 4, we see that we get approx 84, or not approx, not fully 84, we get it. So after then we'll go on like series going to multiple of 42 any. So 21 will be a factor of it, as every multiple of 42 will be divisible by 21, as 21 as 42 itself is divisible by 21, so every multiple of 42 will be divisible by 21. So hence 21 is a factor of n, and n is also a multiple of 42. This both will be true, and the first one will be rejected. So answer will be second and third only. Coming on to next is, we have seen that positive integer a and b each have exactly four factors. If a is one digit number and b is a plus 9, what is the value of a? So it's telling that b and we want a. It's telling that a and b have exactly four factors. Let's consider any random factors of a and b. Let's say exactly four factor. Let's consider 1, 2, 3, 4, anything. And for it is also having four factors. And if a is one digit number, so a is one digit number, let's take any number like 1. And b is a plus 9, so b is 10. So what is the value of a? And it sounds like a tricky question. But we want something that could give us four factors of a and four factors of b. So for that, if we look at trying on dual numbers like 1, so we won't get four factors. If I think a has four factors, so b is also having four factors. For 2, there won't be four factors. For 3, if we look at this, then there are again, and also we need to look like things that mostly we need to look at even integers. So like 4 having 1, then 2, then 4 itself. So 4 will have three factors. 5 is no looking makes sense anything because and also one rule you need to remember that prime numbers have exactly two factors. So remove all the prime numbers and look at the numbers that can gives us more than two factors or means the four factors exactly. So we want looking at the prime number here in case. So we have seen about 5 also. Now if you look at 6, so exactly if 6 is there, so 6 has 1, then it is divisible by 2, then it is divisible by 3 itself, and also it is divisible by 6. So are you getting it as four factors? Yes, 2, 1, 2, 3, and 6. So it has exactly four factors. So if 6 has four factors and b is like 6 plus 9, that will be equals to 15, and for 15 it will be like factor 1, then it will be a factor of 3, and also 5 will be the factor of 15, and also for I think 15. So these are four factors of 15. So see, we are getting the things clear, like we have got four factors of this as condition satisfied, and as condition satisfied we've got four factor of a. So this concludes that our answer is 6. Ramon wants to cut a rectangular board into identical square pieces. If board is 18 inch by 30 inch, what is the least number of the square pieces he can cut without wasting the any of the board? So Raman wants to cut the rectangular board into identical square pieces. If the board is 18 inch by 30 inch, what is the least number of square pieces he can cut without wasting any of the board? Here, without wasting any board. But this line, without wasting any board, concludes the fact that he needs to choose a side length that divides evenly into both 18 and 30. You need to choose a side length such that divides evenly into 18 and 30. So which side length can be divided? So if you consider the greatest common factor between both, it will be like you can calculate, that will be 3, 6, 18. So 3 into 3, 3 to the 6, 6 into 3, 18. And for this it will be 3 into, let's take a 6 only. So 6 into 5. So 6 will be the common factor between both. That will be greatest common factor between both. So if we consider 6 as side, so what is the least number of the square pieces he can cut down? So he's cutting the square pieces. This would give Raman 3 pieces going one way. Three pieces going one way and 5 pieces going the other. This will give this. So he would cut 3 into 5. That would be equal to 15 squares of dimension 6 cross 6. If we consider this things. Also note that this solution ignores the squares with non-integer side length. Potentially dangerous thing to do. After all identical squares, 1.5 by 1.5 could be cut without wasting any of the board. However, to cut few squares that are larger than 6 cross 6, the Raman could cut the two squares of 9 in that case. If it's greater than 6 cross 6, okay, so the 30 will be rejected at 7, 5, so 35. So it won't be able to make 30 inches in that case. So 18. So in that case, Raman could cut only two squares of 9 inches or a one square of 18. That could have seemed like that. From the 18 dimension of the rectangle, neither of which would evenly divide 30 dimensions of the rectangle. Hence the computed answer that could be like 3 cross 5, that is 15. So in short, one more explanation, one short, like there are 18 inches and there are 30 inches. Okay, what is the least number of the square pieces he can cut down using any board? Least number of square pieces. Means we need to select the largest possible squares. Remember, if there is a square and we want to that the largest, we want to do least number of pieces. So we need to reduce the pieces. So we need to increase the size of the square. Okay. So in that case, well, first calculate the largest integer that could divide that both the numbers. That is the HCF of that. That will be like 6 into 3, and here is like 6 into 5. HCF is simply 6. That could divide both. So this would end up giving us a 3 plus going one way and 5 plus going the other way. We would cut approx 3 cross 5. That could be 15. That is 15 squares. And the inch would be 6 inch. And also if we considered the difference, the dimensions greater than 6 plus 6. So in that case, Raman could only cut two squares of 9. That would be 18. And this could not be there. So the board will be wasted some part. So this won't be the least squares. Or you can say one piece of 18. Neither of would be only divide 30. Because we have increased the inches like 7. This could be 35. Which is not at all possible. Or we can't evenly distribute 30 taking a 7. So the computer answer would be 15. That could be evenly divided so that the least number of squares can be cut down without wastage of any boot. Next is if n is the product of 2, 3 and a two-digit prime number, how many of its factors are greater than 6? So the first part is telling is n is product of 2 and 3 and a two-digit prime number. How many factors are greater than 6? Let's take two-digit prime number as 13. Now telling that n is the product of 2, 3 and 13. And how many factors are greater than 6? Is a product of this. Let's create some table condition. So here let's take this for this question 2 into 3 into 13. That will be like 39 into 2, 78. So if n is the product of this, so let's take n as 78 and then calculate its factor. So it will have rocks. So in order to do that, let me number of greater than 6. So we have got 78. First one will be like 78 into take the factors of that. This is 13, let's say. This is 3 and this is 2. So what on what multiplying that gives us 78. So 3 into 6 into 16 gives us 78. And here what multiplying for 3 gives us 78. Simply multiply this. This 13 is a factor of 78. So 13 into 3, then 13 would be into 2, and also 13 itself, that will be 30 into 1. Is greater than 6 by multiplying the third factor, 2-digit right column represents the third factor multiplied by all the other factors. You replace this with any other numbers also get the same. Contains a very good factor, so we number 13 we got so factor of it. So for n, the factors that are greater than 6. So here you can see that all the factors will be greater than 6. And so answer are four factors are there. This is 1, 2, 3, and 4. Move on to the next. M is a positive integer that has factor of 8. Quantity 1, remember when m is divided by 6. Quantity B, m when m is divided by 12. M is positive integer that has a factor of 8. Divided by this 2. Let's take a 6 into 2. Let's take a 6. That is a factor of 8. So if we calculate both the numbers at CF, we get 6. And we want factor of 8, so multiply by 8, so we get 48. 48 obviously have a factor of 8. So let's take that m is a positive integer. It is 48. When remember when m is divided by 6, 8. And remember when m is divided by 12, that will be 4. So if we're dividing by a greater number and dividing by a less number, the same quantity. So if you are dividing by the less number, so obviously at our side we will get more quantity. Yes. And it will be less. So but also we need to consider some more cases. Yes, we are taking m as a 48 here, but so m as a factor of 8, that could be like 8, 16, anything, 24, 32, 40, and 48. And in case m is this, so we have seen that it will be 10, 4 in case it is 24. So it will be like, sorry, we are including the vendor. Just a second. What's on the function? Just 8, 16, 24, 32, 40 and 48, and we want remainder, not that. Okay, so remainder when we divide by 6, so we can divide that 16, that 24 by 6 and 12. So when we divide this, we get the remainder 0, and when we divide by this, we get remainder 0. But if m is 32, then for 5 and we get a remainder of 2. And in this case also, if m is 32, we get the quantity 8. So in one case we are getting that both are equal. The case we are getting 2 and 8. So this is something that is conflicting the things. So definitely the answer cannot be predicted here. The answer is T for 15. Next will be when the positive integer x is divided by 6 and the remainder is 4. Each of the following could be an integer except positive integer x is divided by 6. The remainder is 4. Multiples of 6 are and the numbers with the remainder of 4. And divided by 6. Those 4 greater than the multiple of just 6. So if we are getting for 4, so one multiple is also 0. So one number that will be uh, that is 4, that will be 4. And another number will be 10. There could be 16. This could be 22. And so on. So here we can see, can x be divided by 2? So when this divided by 2, the listed value of x are divisible by, so x could be 4, 10, and all things to be there. So x can be divided by 2. All of the listed values of x are divisible by 2. So this could be an integer, but you want that, accept that. Then for 7, if we say 28 will be divisible by 7. This could also be an integer. Then for 11, 22 could be divisible by 11. This could be an integer. For 17, when coming on to this, will be 34. So 34 can be divisible by 17, and this is also an integer. So it's asking each of the following could be also be an integer except we want except one. So except one is, I think, this. Let me check that. None of the listed value can be divided by 3. So yeah, our answer is this, x by 3. So thank you for watching this video, and we'll continue from 17 question in the next lectures.